Subject concrete structures, chapter design of slabs, topic numerical number 2 on one-way slab. So students, now let us solve one more numerical so that our concepts get further strengthened, further stronger, right? The numerical is the factored load, live load plus dead load. It is a factored load, right? That is why I am underlining it is a factored load acting on a simply supported slab. Simply supported slab of effective span. Effective span is given to you 8 meters cross 3.67 meters, right? Now it says that the factored load is 14.63 kilonewton meter. 14.63 kilonewton meter. The effective depth small d of the slab as per IS 456-2000 recommendations would be take M15 Fe415 and L effective by D ratio is given to you. So no need to worry. So in question L effective by D ratio is given to you. If it would not have been given, what would we have taken for Fe415? That is 28, right? Because it is a simply supported slab. It is a simply supported slab, right? Okay. Now, how to solve this numerical? Now, the first thing which comes to my mind is that let's just apply this formula L effective by D. It should be less than or equal to 20. From here, I can get the value of D. You are very correct. This is the method that we can get the answer. But that is the deflection criteria, right? Deflection control criteria. But also, moment has been given to us in the question. So suppose that by this thing we are getting it is 115 mm, and by the moment criteria if we are getting a depth as 150 mm, so which one will we adopt? We will adopt this one. It means that we have to check the effective depth both as compared to both with the deflection control criteria as well as the moment criteria, whether that much of effective depth can resist the moment or not. If it cannot resist the moment, then there is no fun of providing the effective depth as per the deflection control criteria. Clear? It means that in this question we have to take two steps. The first step would be to determine the effective depth from the deflection control criteria, and the second step would be to determine the effective depth from the moment criteria, right? The effected load, that is kilonewton, sorry, not meter. Kilonewton, effected load, right? Kilonewton, right? Okay. So this is what we have to do. Clear? Now first of all we have to check whether the slab is a one-way slab or a two-way slab. Already I have given to you the numerical number one-way slab, so surely it will be a one-way slab. But in question it will not be given to you that this numerical is a one-way slab. Either it will be mentioned as in the previous question was mentioned, or there will be nothing mentioned because here the effective span is given to you. So what we have to do? First of all we have to see whether the slab is a one-way slab or not. If Ly upon Lx comes out to be greater than 2, it is a one-way slab. If Ly upon Lx comes out to be less than or equal to 2, it is a two-way slab. So first of all, let us check how much Ly upon Lx comes out to be. So Ly upon Lx it will come out to be 8 divided by 3.67, right? So 8 divided by 3.67, it comes out to be 2.17. 2.17, which is greater than 2, so obviously it is a one-way slab. So first of all we have to check whether the slab is a one-way slab or a two-way slab. Now if it is a one-way slab, it will be designed exactly as the singly reinforced beams are designed. Clear? Now first of all let us calculate the effective depth as per the deflection control criteria. Okay, so this numerical is very simple. Don't get confused that why so much details have been given to us if we can directly apply the formula. Yes, you can apply the formula, but again you have to check whether this much of depth which is coming out from the deflection control criteria, whether it can resist the moment produced by this factored load or not, right? So now solution. It is a one-way slab. First of all we have found that it is a one-way slab. Clear? Now from the deflection control criteria I can say that L effective divided by D, it should be less than or equal to 20. Clear? Now what is L effective? Effective span is given to you. Again, when I was telling you about the concept of one-way slab, now this is a longer span, this is a shorter span. On which length will have that deflection? The shorter span, not the longer span, right? So on the shorter span we will have the deflection. So this span will be taken as the L effective, right? Not the bigger span. That is 3.67 divided by D. It should be less than or equal to 20. Let us see how much D comes. D should be greater than or equal to 20 into 3.67. Let's see how much it is coming. 20 into 3.67. It comes out to be nearly 73.4 mm. So D should be greater than or equal to 73.4 mm. 73.4 mm as per the deflection control criteria. Clear? Now let us see about the, you can say the factored load is given to you, right? Now if factored load is given to you, you have to determine the moment. And I told you, even if I haven't told you, what is the maximum moment in a simply supported beam? If it is simply supported beam with a UDL, if it is a simply supported beam with a UDL, what is the maximum moment? This is a bending moment diagram. It will be WL square divided by 8. I hope you remember structure analysis, basic structure analysis, right? So WL square divided by 8, right? So how much the moment, factored moment will be? W is given to you, the factored load is given to you. So the factored load is 14 points. So moment MU will be equal to 14.63, right, into L square. L is 3.67, 3.67 square divided by 8. So how much the moment is coming? The moment comes out to be 14.63 into 3.67 square divided by 8. It comes out to be 24.63 kilonewton meter. 24.63 kilonewton meter. I hope everybody is getting the same answer, right? 24.63 kilometer. And try to solve the numerical not with this handy calculator, but with the online calculator, or you have also have an app on Google Play, right? The scientific calculators. 24.63. Now what I have to do is that I have to assume the section to be a balanced section, because the area of steel is not given to you, right? If area of steel would have been given to me, what would I have done? I would have, you can say, compared with the moment resisted by the steel, but here the moment resisted by the steel is not given, because the area of steel is not given to me. So I have to assume, let the section be balanced. Let the section be balanced. Let the section be balanced. Clear? Okay. Also, I told you that whenever question is given to you, you have to assume the simplest case, right? Whatever the values have been given to you in question. So for a balanced section, we know that moment of resistance will be equal to 0.36 FCK into XU into D minus 0.42 into XU, right? 0.36 FCK XU into B. XU into B is also there, right? B is also there. D minus 0.42 XU, which is a lever arm, right? So how much is XU? XU, we know that for Fe415 steel it is 0.48 into the effective depth. Clear? Now from the first criteria, the deflection control criteria, our effective depth was coming out to be, I guess, 71 point something, right? So 3.67, 20 divided by 3.67, 3.67, we actually adopted 3.67 divided by 20, it came out to be into 1000, it came out to be 183.5 mm, right? I am writing it also, right? 183.5 mm, it came out to be. I guess I did some calculation mistake. I wrote 171 point something, right? I guess I divided this by 3 point something, right? So D should be greater than or equal to 3.67 divided by 20. 183.5, right? 183.5, yeah. So this was the effective depth as per the deflection control criteria. Clear? Now this is the moment, right? So moment. Now what I have to do is I just put this value, whether the effective depth which I require to resist this moment, and then I have to compare. For example, it is coming out to be 183.5. If I, let us say, apply 183.5 mm depth as per the IS code, but suppose that 183.5 mm, if it cannot resist this moment, then there is no fun of providing this depth. I have to increase the depth otherwise. Clear? Now let's see whether this whether the depth can, whether how much depth should be provided to resist this moment, right? The moment is 24.63. So 24.63, that is kilonewton meter. Let us say multiply it with 10 raised to power 6 for Newton mm, because everything on the right hand side will be Newton mm. It will be 0.36. What is the grade of concrete? 15 into XU. XU is how much? 0.48 into D, right? So 0.48 into D into, in bracket we have D minus 0.42 into 0.48 into D. Clear? So it will be equal to, let me, 24.63 into 10 raised to power 6. Let me simplify it further. So it will be equal to, it will be D square. If I take D common, it will be equal to 0.36 into 15 into 0.48 into, if I take D common, it will be 1 minus 0.42. In bracket we have 1 minus 0.42 into, sorry, I did one just small mistake. I actually forgot to multiply it with B, right? So B also has to be multiplied, right, into B. Now the question is, sir, how much this B would be? I told you that whenever you are designing your one-way slabs, your B is actually of 1 unit, usually 1 meter, right? So because I told you that, for example, you are designing a one-way slab, you take a strip of width of 1 meter. Remember it, right? And then you multiply it with the span. So here the B will be equal to 1 unit or the 1 meter. 1 meter means 1000. 1000. Let me write here also. B will be equal to 1000 mm or 1 meter strip. Clear? So if I solve it, the D will come out to be 24.63 into 10 raised to the power 6 divided by 2.07 divided by 1000. Let me take the square root. It comes out to be 109.08. It comes out to be, D comes out to be 109.08 mm. Now let us compare. So I told you that from the deflection control criteria, the minimum depth should be 183.5 mm. From whether the this can resist the moment or not, to resist this much of movement generated by this load, the minimum depth would be 109.08 mm. Even if I apply, you can say, a thicker section, again it can resist this load, because it would be beneficial for me if I apply thicker section. Because why to apply the thicker section? It should also meet the deflection control criteria. So we have 109.08 and we have 183.5. So what would be the answer? Answer would be 183.55 mm. So which one is the answer? See, 109 was also given to you in question, right? 135, this is the correct answer. Greater than or equal to 183.5 or 144 mm. So I hope that you have understood numerical number 2 on one-way slabs. So one-way slab topic was about this much only. More I have taught you even more whatever was in the syllabus, right? But we can expect in gate examinations. Let's move forward to the next topic, next video about the two-way slabs, and then we will solve some numericals also. So let's meet at the next video. Thank you.